My name is Rahman, and I am your chemistry tutor on Chemistry Clarified. So Chemistry Clarified is a channel that I created just so I can make chemistry very simple for you, because I noticed that chemistry has been one of the most challenging subjects for students right from the secondary school level to the tertiary education level. For this reason, we have to bust all these myths about chemistry. So we have to prove that chemistry is not really that hard. It is just things that we can see around us. And so far on this channel, I have dropped some video, one on introduction to chemistry, another on the nature of matter, and 2 videos on separation techniques where I discussed 14 separation techniques that we have. Now, today we just want to look back and review everything we have talked about so far on this channel and ask ourselves 1 or 2 questions to really see how we are catching up. So the first question is going to be, what is chemistry? So that is where we are going to be picking up. What actually is chemistry? So as I've said earlier in the video, so it is going to be a quiz and revision. So I'm going to be asking the question and answering it so that we are going to be refreshing our memory on the things that we've covered. Now, when I ask this question, can you try to give an answer to it yourself first? If yes, pause this video for a while. Try to give an answer to this question. What is chemistry? What can you think of where you ask the question? What actually is this chemistry that we're studying? Now, if you're able to give an answer, that's fine. If you are not, no problem. I'm just going to help you out. What is chemistry? Chemistry can be defined, so this is one way I like to define it, as the study of matter. But you might say that is too short. Chemistry is the study of matter. But we can make it a little bit more inclusive. We can make the definition a little bit more inclusive. We can say chemistry is the study of the structure, composition, and properties of matter. That is, a better definition is, chemistry is the study of the structure, the composition, and the properties of matter. That is why there is no way we are going to talk about chemistry without talking about matter. So chemistry, we always define chemistry using this particular matter. Now, what is matter? We all know what matter is, right? We say matter is anything that has mass and occupies space. So that's another question again. What is matter? So we can say matter is anything that has mass and occupies space. Beautiful. Now, don't let's forget where we are coming from. What is chemistry? And we said chemistry is the study of the structure, composition, and properties of what? Of matter. Now, what is that matter that we are studying? Matter is anything that has mass. I have mass. So, if I stand on a balance, the balance is going to check my mass. So that means I have mass and I'm occupying a certain amount of space right now. My glasses has mass. If I put it on a scale in the laboratory, I'm going to get some readings and it's occupying some particular space. So that is matter. My matter, this board, this whole building, in fact, a droplet of water, something even smaller than that, something as small as an atom, or something that is even smaller than an atom, like an electron, is an example of matter. For this reason, we can say chemistry is the study of everything, because almost everything is matter. So, and with chemistry, we are just essentially trying to study this matter. Matter is like everything. That is why I like saying chemistry is the study of everything. So, and don't let that puzzle your mind. Yes, we are going to study everything in chemistry, but we are going to take it one step after the other. We are going to look at them one by one. Now, we already know what matter is. We know what chemistry is. Now, that will take us to a concept in chemistry. The concept of trying to understand what this matter is. Because before we study something, we should actually know what that thing is. And in chemistry, These three criteria are what you are going to be using to study the matter. When we have matter, we are going to look at the structure of that matter, we are going to look at the composition of that matter, and we are going to look at the properties of that matter. Now, each of these things can be divided or subdivided into other categories. For instance, I'm talking about studying matter in terms of its properties. Now, am I talking about the physical properties or the chemical properties? Don't worry, we are going to get there in a bit. So far, we have answered two important questions in chemistry. What is matter? What is chemistry? Which is chemistry is the study of matter, and chemistry is the study of the structure, composition, and properties of matter. And matter that we are studying is anything that has mass and occupies space. Anything that has mass. What is mass? So we have been talking about mass. And in physics and chemistry, we are going to be talking about mass very, very often. So we can simply define mass as, we can say, mass is the quantity of matter contained in a body. So next time you go to an hospital and then you stand on a scale and they tell you this is your mass, what they are essentially telling you is that this is the amount of matter. You already know that matter is anything that has mass and occupies space. So the amount of those things that is present in you, that is what they are measuring. And they are giving you the results in kilograms or grams or pounds, depending on where you are. Now, mass is the quantity of matter contained in a body. So, if this particular matter, this marker is a matter. So, if this particular matter has a lot of matter inside it, it is going to have a higher mass. So, let's say inside this, there is a lot of matter. So, it's going to have a higher mass than this, which is just an empty case that has less matter in it. But if I should put my glasses inside this, more matter is going to be inside this one, and this one may now have more mass than this one. So that is just what mass is in essence. Now, we have talked about matter, we have talked about mass, and we have talked about chemistry. Now, let's talk about matter more in details. As you might have guessed, there is no way we can talk about matter without talking about the states of matter. I hope every one of us can tell us the three most common states of matter. We have solid, right? We have liquid, and then we have gas. These are the three most common states of matter. Although you might have heard of plasma before. And they ask you, what's the state of matter of fire or thunder? Or what is the state of matter of the inner part of the sun? Or all these things. You know that they are plasma, but we are not going to dwell much on plasma in this particular lesson. So, in the future, we may talk more about plasma. We all can give examples of a solid. In fact, we can use just one matter to give an example of this thing. So, we can say, iced water is an example of what? Solid. Liquid, normal regular liquid water that I can drink is an example of liquid water. And vapor, when you are cooking, you see some steam and the water becoming gas. So that steam is water vapor, and vapor for gas. Now, when we talk about this state of matter, it will be incomplete if we don't talk about the changes of state. Change of state. Now, again, we are going to be focusing on these three states of matter. For instance, let's say you have water and you put it in the refrigerator. What do you get? You get an ice block, right? So, and that is water in what? In solid form. So, that is solid. This solid iced water, you bring it out of the freezer. What happens to it? The heat from the atmosphere gets to it. And when that heat gets to the ice, what happens? It is going to melt and become a regular liquid water. So you call that process melting. That process is called melting. So this is called melting. And this is when you put out your water and you allow it to melt and it becomes what? liquid. Now, when you melt, if I should heat up this marker that is in solid form and allow it to melt, and my marker is now in liquid form. Now, that is called melting. When you are burning your candle and it is melting, so that is an example of a change of state called melting. But this water, I can just easily put it back in the freezer and freeze it back to what? Back to solid. And that process is called, as you have guessed, freezing. Or you can also call it solidification. Now, but you are not satisfied. After you have increased the temperature of this particular water and it is now liquid, you wanted more, so you continue eating the liquid, and at the end of the day, this liquid became something we know as a gas. So what do we call the change of state from this liquid to the gas when your water starts becoming vapor? That's it. We call it what? What do we call it? It starts becoming vapor, so we call it vaporization. Or evaporation. So when your liquid is becoming gas, that is vaporization or evaporation. But this gas, can you turn it into a liquid back? Of course, yes. Just like the freezer that turns your liquid back to solid. We have an apparatus in the laboratory. Its name is condenser. The name is condenser. This condenser, it has some pipes inside of it, and regular tap water is just going to flow inside it. And what that tap water is going to do is that it's going to cool the temperature inside the condenser. And when it is cooling the temperature of the gas that is passed through that condenser is going to cool down too. So that gas is going to come down from vapor and come to the liquid state. So that is the job of a condenser. And you use the condenser to convert the gas into a liquid. And because the name of the apparatus is condenser, you can call it condensation. Just like freezer, freezing, condenser, condensation. But there is this part missing. Can we go directly from solid to a gas without passing through the liquid phase? Like when you just eat something, it just becomes a gas. What in the world is that? Yes, it's actually possible in chemistry. And that is what we call sublimation. Like the substance just disappears into thin air. So we call that in sublimation. An example of a material that can do that is iodine. Another one is camphor. Another one is ammonium chloride. This is the chemical formula for ammonium chloride, NH4Cl, ammonium chloride. So all these particular substances can sublime, that is, they can go directly from solid to gas. They are little magicians. Instead of going through the liquid phase, it just disappears into the thin air. So that is when you go from solid to gas. And when you go from gas back directly to the solid without passing through the liquid phase, we call that deposition. Deposition. So that's a deposit. This is the change of state of matter. So at the temperature where this solid is going to become the liquid is called a temperature known as melting point. Melting point. As is the point at which it is going to melt. The point at which a solid is going to melt, that is, a solid is going to become a liquid. An example is the melting point of water. Water must get to a temperature of 0 degrees Celsius. Ice water must be at 0 degrees Celsius before it melts. And that's the melting point of ice. And when you boil your water, this one is pretty common. When you boil your water, its boiling point, that is the point at which it is going to vaporize, is known as boiling point of water. I don't know how to spell water here. It's what? 100 degrees Celsius. So, these are the important things that we need to know under state of matter and change of state for now. Now, under matter, we can look at matter from another perspective, different from the state of matter and the change of state. Let's quickly do that. Remember where we got here? We're defining chemistry and we made mention of matter. So, we are trying to look at how we can study chemistry, how we can study matter in chemistry. Now, we have looked at matter in the form of its state and the change of state it could undergo. How about when we look at matter in this other perspective? If I get a matter in my hand, what are the things that I'm expected to find inside this matter? Let's look at that. Whenever you have a matter, it can either be two things. This is talking about all the matter in general. Me, you, this camera, this tripod, the chair, the table, the building, everything can be categorized into two. All the matter that we have can be categorized into two wide categories. Now, the first one is either that matter is a pure substance. Either it is pure or it is an impure substance. So everything in the world can be classified into these particular categories. If it is pure, it is either an element or a compound. So if it's a pure substance, if you have a sample now, you don't know what it is, just say this is a matter. So if you want to classify it, you have to check, is it a pure substance or an impure substance? If it is a pure substance, it can either be an element or a compound. But if it is an impure substance, it is a mixture. When something is impure, it is a mixture. So, and this mixture can be subclassified into two. Either it is an homogeneous mixture, that is, either it is an homogeneous impure substance or homogeneous mixture, or it is an heterogeneous. Now, give me some time. I'm going to explain all these things. Heterogeneous mixture. Now, this is a very basic classification of everything that we have in the universe. Now, let's put this thing to test. The air we breathe in is an example of matter, right? So, that is something common that everybody knows. Now, let's try to classify that air. If you look at air, in which category does it fit? Air is matter, no doubt. But is air a pure substance or an impure substance? I can hear you say it's a pure substance. No. Air is not a pure substance. It is an impure substance. In fact, it's a mixture. A mixture of what? Of some elements. That is, when you have two or more elements that are not chemically combined together, you call it a mixture, but not just elements. Even if it is two or more compounds, or an element and a compound, but they are not chemically combined together, that is a mixture. If you look at the composition of air, you are going to find some nitrogen in it, you are going to find some oxygen in it, so you are going to find maybe a very small amount of argon in it, so you can also find some CO2 in it. So in some cases, you can also find some poisonous CO in it. So you can find a lot of things. You can find some H2S in it, some poisonous stuff inside the air. So this is a mixture. All these things are inside one thing and they are not chemically combined together. So it's an example of an impure substance. But if you have a pure tank of oxygen, although it is not always pure, they sometimes mix it with some helium. Maybe that you want to give to a patient at the hospital, or maybe the one that a diver wants to take under the sea. What do you call that? It is just oxygen. Only oxygen is inside that. So that is a pure substance, because it doesn't contain any other impurity. How about if you have some salty water? There is salt and there is water. That means it is an impure substance, which means it is a mixture. So now, if I have a salt and water, that is an example of an homogeneous mixture. What is an homogeneous mixture? An homogeneous mixture is a mixture that is uniform, uniform. It is homogeneous. So if you look at it from the top to the bottom, it is the constituents are going to look uniform. And if you put a straw to the top of that particular salt water, you are going to taste the same amount of saltiness as you put it to the bottom of the particular cup. So it is uniform. It has uniformly dissolved. The salt has uniformly dissolved in the water. So that's an example of an homogeneous mixture. But if you have sand inside water, this is going to be an heterogeneous mixture because the sand is just going to sink to the bottom while the water remains afloat. So this is an example of an heterogeneous mixture because it's not uniform. It has different segments. So for this reason, it makes it an heterogeneous mixture. So an example of an element, a pure substance that's an element, is helium. Helium is a rare gas that's always inside decorative balloons. They pump it inside decorative balloons because helium is a very light gas. Remember, it's a gas, yet it's an example of what? Matter. So it makes the balloon very light, like all these Goodyear balloon and stuff like that, decorative balloons. So this is an example of a pure substance. An example of a compound is if you have pure water. This is the chemical formula for water, H2O. So I'm just going to write it as that. H2O. This is water. This is a compound. Why is it a compound? Because it is a combination of at least two elements. This is an element, hydrogen. You have two hydrogen. That's why you have two here, H2, two hydrogen. And you have one oxygen. Well, I don't need to write H2O1. So I already know that this is one oxygen. No need to repeat that one. So this is hydrogen and this is oxygen. It has two elements. For that reason, we call it a compound. But these elements are chemically combined together. Because they are chemically combined together, we call it a compound. But this mixture, it may have two or more elements, but because they are not chemically combined together, they are just physically combined together, you can break them apart. I can take my oxygen from my air, my argon, my nitrogen, through some chemical processes. Through some physical processes rather. So, and that's the reason why this is an impure substance, why this is a mixture. But this is the simplest unit water can. If you want to break it, you have to break it chemically. You can't break it physically. So you can't heat water to the point that the hydrogen is going to break apart and the oxygen is going to break apart. It's going to become vapor, and if you just cool it down, you get the water back. It's not going anywhere. So this is an example of how you can classify matter. So remember, an element, this is the simplest unit that a substance can occur in. All elements are atoms. So we have different atoms like hydrogen. We have an atom of hydrogen, an atom of helium, an atom of oxygen, and an atom of carbon, an atom of argon, nitrogen, and so on and so forth. An atom of sulfur. So we also have compounds, and these compounds are when you have at least two elements. This is another example of a compound. I stated it before. This is a compound. Ammonium chloride. When I was citing an example of substances that can sublime. So this is an ammonium chloride. Notice that this one is also a compound, but it has more than two elements. This is nitrogen, one nitrogen, four hydrogen, and one chlorine. This is 1, 2, 3 elements that are inside this particular compound. So a compound might have more than two elements, but it must have at least two elements for it to be a compound. But you might wonder, you might have asked something like, okay, turn on the O2. And you want to refer to as something, they refer to it as O2. What does this mean? Is this a compound? No. Is this an element? No. Oxygen as an element. This oxygen, just one of it is an element. But if you have it as two, it's not a compound. Why? Because you only have one element present here, one oxygen. So what is this? This is a molecule. So you call this a molecule of oxygen. So I think you all understand what matter is now. And let me quickly brush through separation techniques too, so that I can call it a day on this video. We are talking about separation techniques. They are the methods in which we separate impure substances or mixtures. When you have a mixture, sometimes you may need to separate it. For instance, seawater, we have it in nature. It is occurring in nature, and sometimes we may need to separate it into pure water and get our table salt from it. How can we do it? You don't need some fancy chemistry equipment. You can use a separation technique known as evaporation. Remember in change of state, we talked about evaporation. So you can use evaporation to separate it. Using evaporation, what you are going to do is that you are just going to heat up the particular mixture of the salt and water. So you just get some sample of seawater. You know, seawater is salty. It has water and it has sodium chloride, which is the same salt that you use at home. So the table salt you use at home is called sodium. This is the chemical formula for sodium, Na. So don't worry, we are going to get so why hydrogen is hydrogen and we represent it as H. But sodium is sodium, SO. This is sodium, but we represent it as Na. So don't worry yourself now. So sodium chloride. So we represent it as NaCl. This is the same salt that you put in your food that you eat and stuff. So this sodium chloride is present in abundance inside the seawater. So for us to get the sodium chloride, we just get a sample of the seawater and we evaporate it. We let it evaporate. The water is going to dry out. When the water dries out, that's what is called evaporation. You are going to be left with your raw sodium chloride ready for consumption. So that's one of the separation techniques. We have 14 separation techniques that I explained in that previous video, so you can visit it to see a handful of separation techniques and how you can apply them. So this is where we are going to be putting an end to this particular video. If you love this video, don't forget to share it to your learning group, like this video, subscribe to this channel, and see you in the next video.